Thank you so much, Bob, for joining us. We really appreciate it.
And I'm going to head out.
Okay.
Hey, see you,
Thanks,
Joe. Nice going.
All right. Bob Heil is going to talk to us about antennas and probably a lot of other things as well. Bob was first licensed in 1956, and amateur radio was the foundation of his multiple careers in the sound reinforcement industry. I love that term. You know, speakers. His microphones bring high-quality articulate audio to amateur radio, and we really appreciate that. So thanks, Bob, and it's back to you.
Okie dokie. Thanks for having me. I've been here, we were here last year, I think, and I always enjoy bringing some of the science of this great hobby. There's so much that we can all learn, and I learn every day. Well, last time I was here, we got into some of my beginnings of where I came from and how I got started, and I'll do a quick run through if some of you didn't see some of that, where at the age of 12, I started playing the Hammond organ. My parents, and were not wealthy people, bought me a Hammond organ. And what's this got to do with ham radio? You're going to find out in just a minute. 3 years later, I became a professional playing at the Fox Theater, the Monty Wurlitzer. But why that's all important is I learned to listen. Listening is a mental process. Everybody hears, but listening is a little different. And I learned that all from voicing and tuning all of those pipes. There were about 3,500 from 1 inch to 32 foot. Played organs all over the world. And as I say, it's so important to my whole life that I was able to listen. That same year I got the job at the Fox, I became a ham. K-N9EID lasted about 2 weeks, and then I became a technician for 17 years. Why? Because the sunspot cycle was wide open all the time. It was so wonderful. Today, 6 meters is nothing but a contest band. What's your grid square and they're gone, or the FT8 and all that. But I really got involved in that. We had great possibilities to make things happen with antennas on 6 meters. But I really loved and enjoyed all the time. And I think a lot of you know about my years on the road with so many of the artists that I'm still doing. I lost one of them last week or so. Jeff Beck was a great friend and client. And oh boy, it's really tough to lose some of your good friends. But we want to talk today about antennas. Antennas they're everything. Once you get your audio adjusted and you get your transmitter adjusted, it's time to really get into some of the things that we need to know about antennas. And I don't see a lot written about it. We're going to get into some very interesting things. One thing I want you to be aware of, don't try this. Somebody pretty crazy that did that. Oh, golly. The best antenna, absolutely the best. Nothing beats a resonant dipole. It really is very important. You can put some traps in it and do 75 meters and 40 meters and on. But it really makes things happen with a resonant dipole. And I really enjoyed some of the things in the early days, but I learned something from Art Collins. First of all, I got into some phasing. We're going to touch that in a minute. But Art wrote a piece about the height of your antenna. You see, a dipole antenna has two rays. You only think about the one direct ray, but there's a reflected ray. And that reflected ray is so very important. And you have to figure out how to get them together. That would be good, wouldn't it? Well, it's very easy. It's about the height of that antenna. And I find it interesting that I don't see anything in the manuals talk about this important fact. They just think the higher it is, the better. Well, that's not true. You need to mount it in wavelengths, a quarter wave, an eighth wave above ground. Those are the important factors. I didn't, once I saw that, I didn't know if, is that really true? So I took a month. This is all on 6 meters now, but it could be any band. What we did is I had a group that we met on 40 meters every night. I said, okay, here we go. I had a reference antenna at 20 feet, of course, a resonant dipole. And every night I'd come on with a different antenna or at different heights. We got a reference. We'd station in California, New Orleans, Florida, Parma, Ohio, and the station at the Collins plant. And so here we go. We'd start on the 20 foot. And one night I'd have it at 30 feet. It was a little better. Next night I came in, gotta be better at 40 feet. So I'd go to 40. It took a lot of work during the day, but that worked okay. It was a little better, not gargantuous. Went up to 50. You would think, really, this would help. So then I took Art Collins' great findings and words. One night I came up at 33 feet. And it's like, whoa, it was much better. So the next night I came on and it was at 66 foot. I had a 70-foot tower. And in those two instances of the quarter and the eighth wave, yes, the signals were better than just throwing it up at 40 feet. You're better at 33 feet on 40 meters. And so that really got me to thinking. Well, then I'd read a lot about phased arrays, and I wanted to know a little more about the phased array situation. And so we took off and started doing a little experimenting, as I say. And it was really wonderful when I got into it because I learned so much, and I learn things every day. And so what we want to do is to try to help you understand how phased arrays work, are just reflective waves. And I'm going to do this with the use of just trying to show you some things. I have a thing here, come on here, using some balloons. And we're going to look at the omnidirectional, and then we're going to look at how this works with your reflective front and back. So let's take a look here as things pop up. Okay. All right. What we're going to see here first is an omnidirectional pattern. That's just good old quarter wave, and it's resonant, but it's equal in all directions just about. But then if we want to really make things happen, just by adding a reflector, look what happens. Let's look at the dipole first. With just a regular dipole, you're equal both sides. And this antenna is running north and south, so our east and west lobes are equal. But what happens if we do a little phasing? We go out and add a reflector, but we use a delay line that will delay that reflector. What happens to the signal? You see what happens. We have a much stronger source in the front than we do behind. So here's how you can do that. I put up a couple of dipoles at 65 feet, and they're 65 apart. There again, playing with wavelengths. But you'll notice that the feed line has a delay line in it. That's the little red part you see. And by switching a remote relay one to the other, we can have some very interesting differences of the two dipoles. And we switch it the other way, and we can go back the other direction. This really, really works great. And so I played with that several years on 6 meters, and it really worked. Well, later on in life, in 1976, I'd been off the air for about 12 years. I was on the road with all my rock and roll buddies doing their audio. And when I got back on the air, I got an extra class license because I wanted to make sure that we had things going right. 6 meters was dead. So here we go. I put up a pair of phased arrays on 75 meters. And it was a wonderful situation. I really, really enjoyed what happened here.
And the poles are 64 foot
As I
apart.
told you, I put up the telephone
These are
poles.
500 foot from the
That worked
operating position.
extremely
fed
well.
with RG2.
Got them from the local telephone company. They had a lot. You go to them, they'll give you poles. They have 90 footers that are cut off. But there's that again where you see the phasing line and the remote switch. These antennas are 500 foot from the station here, and that's what they look like. I had two 10-foot aluminum masts. I didn't want anything to stop any of the reflections. But from that 500 foot, we come into one of the variable tubs, and I had the relays in there. And again, we could switch back and forth. And it was just a wonderful, wonderful thing. Phased arrays are something special. You also can do them with verticals if you like. That's an easy way to do it. Same deal. You have that phasing line for 75 meters. That phasing line is very important, and you can do that with a remote with a local switch in your station. But it's best really to make it happen remotely. Phasing line on 40 meters was 22 foot, and so on. But that really works wonderful. And in doing all of this, you're going to help your signal both in receive and transmit. The relays that I used were Ameritron. I also had DX Engineering on my 40 meter one, but the Ameritron relay works great. They have several versions of that. I only used two of them, east and west, but it worked. The relays are very, very good, and they're double pull, double throw. And I paralleled them, so we had lots of good contacts and so on. But what I didn't like about them is I don't like rotary switches. And that's the box that comes with them. I said, nah, I'm going to get rid of that. So I go to Antique Electric Supply. Write this down. If you don't take anything away from this today, Antique Electric Supply, they have everything that we need for many things in amateur radio. And also have tubes. They're in Mesa, Arizona. But I bought some Les Paul guitar switches, and you see what I did with them. I don't have a rotary switch. I can rock back and forth. That's another thing that was really good. I can easily go back and forth because those are spring loaded in one position and locked in the others. And that really was great because you could see what was coming in from east or west. I do everything here in the station. There's 35 relays and all the stuff you see behind me. And I switch the antennas. I switch all the radios in each of the consoles. I have two consoles, the one behind me and that one's over to my right. One of the interesting things you'll notice right there, that's my original Harvey Wells, 1956, original tubes, caps, everything. It works great. Most of my operations done on AM, as you can see. A lot of that's been with me for all these many years, since 1956 through the early 60s. And the ICO up there in the top corner, that's one of my faves. But it's just wonderful to be able to use some of the old stuff. But I do all the switching with them. And any other switching I do with the Les Paul guitar switches. Now, let's talk back about that dipole again. You can do a lot of things with a dipole, a resonant dipole. If you don't have the room to stretch it out, you can do something like this. I know a couple of friends that they had a tall tree, and they used a tree as their center support and pulled the each end out away from the tree a little bit. And it works great. Don't be afraid to try anything. That's one of the big problems that I hear today. Oh my, it might not work. Put it up. I've done so many things that weren't by the book, but I thought, I wonder if this will work. And it worked. Does it work really great? I don't know. It worked. Could it work better? I don't know. Probably. But don't be afraid to try anything when you're playing with antennas. The absolute, no question, without a doubt, the best dipole is a dipole that was designed by the Massachusetts Institute of Technology in 1938. The government went to MIT to have them design a very broadband antenna that they didn't need antenna tuners. Antenna tuners are a big to me. I hate them. Why? Because they suck power. No, mind that. Well, yes, they do. You're better off to not have an antenna tuner, but you gotta have what? You know what? Gotta have resonant antennas. That is why my dipole, the coaxial dipole, is the answer. This thing is the outskirts from 3800 to 4K, the entire 75 meter phone band is just under, the ends are right at 2 to 1. Get down into the center and are absolutely 1 to 1. And so this is a wonderful antenna. You really need to look into the MIT. Now beware, there's these things called bazooka. I hate the word. And I was like, what are you doing? No, we want an MIT coaxial dipole. And all of the dimensions that gives just absolutely amazing antenna. And I have them up for just about every band. And then there are things you want to play with. I have a lot of people that they get into the hobby and they don't want to spend a lot of money. This cost me, I think I spent $2.45 for this thing. It was speaker wire I had to get a coax connector and then made a little plate out of it was the top of an electrical box that I had, drilled that out and away I went. And these are the things you can have fun with. Don't ever think this is a joke. This thing really works. Yo-yo antennas, they're out there and they work extremely well. One of the biggest problems that we have is how to mount. You never, 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 never use pulleys. You got that? Never. Why? I just heard a guy yesterday on 40 meters. He was talking, oh man, I lost my antenna because my pulley froze up. Yes, it did. You don't want to use pulleys. I don't care if they're marine. I don't care if they're whatever they are. They're going to freeze up. So what you do is you use a carabiner down there in that bottom left. They make locking ones like that. What a great thing. I use 6-inch stainless steel. Beautiful. You can get them at Lowe's, Home Depot, or maybe even Walmart. But they want to be stainless steel. But you will never, ever have a lockup. The rope just goes up and down, so simple and so easy. And those are things that you want to pay attention to. The other, up in the right corner, that's how I make some of my center insulators. I just take a piece of fiberglass board or plexiglass and you drill a couple of holes and you weave it in and out, and then to a coax connector. I've even done some without a coax connector. I do 2 more holes and bring the feed line up, and so it's secure. And then cement those down really well. Or you can do it in the bottom there with some plexiglass. And again, here are some sloper ideas that really work well. And these are things that, again, don't be afraid to try. That is so important. And if you have a tower, well, you can run the feed line up to the tower and often running to the antenna. Slopers work very well. They'll give you a little bit of directivity, and that just makes it so simple. But I like to use wire if I'm just doing a wire antenna for one frequency. I use MFJ's wire. They've got a 7-strand antenna wire, steel that's in copper plated. I don't think it's copper plated, but coated. That works terrific. I use it for several of my experiments around here, and it's very, very sturdy. I've never had any of it break, so you want to try some of that. The only problem I had when we moved to this location so many years ago is the lot's not very big, and I wanted to do a full-size 75-meter antenna. I didn't do the bazooka here, as you're a bazooka fan. I didn't do the coaxial because I have a neighbor across the street that has a beautiful 70-foot tree, and I have a neighbor on behind me that's got a 70-footer. The neighbor across the street, her husband, who's deceased many years, I never had met him. he was a ham, so she's a little lenient to amateur radio. In fact, she likes it. So, okay. So I used one of her trees and the 70-footer behind me. So I need to have it kind of like inconspicuous. Can you see it? That's running across a busy street. She lives across the street from me. And that's running across the street. And it works so good because I needed to do an antenna that was focused on east and west, and she's across the street south of me, so that really worked well. And those things work great. For everything else, I use a mount on my my house here. That's about a 30-foot roof, and so the antenna's up 35 or so feet. It's a Force 12 SS. Works everything I need. I had up a 6-meter antenna here for a couple years ago, but I took it down. 6 meters is a waste to me. So I said, see you later. And then I put the Force 12 up at the top, and it helped a little bit. A lot of people want to do balanced lines, feed lines. Well, there is some means to that, where if you have an antenna, if you get a couple 100-foot, even the 75-meter one, you can use open wire into a balanced tuner, not just some little tuner, but it's got to be an LC tuner. And then you can work all kinds of bands. It's not like a Yagi or so on, but you can work a lot of frequencies with that situation. But the situation is that balanced line. It gets wet, and SWR goes to heck. It's if it gets any snow and stuff on it, you're out of luck. Well, here is something that I learned from one of my great mentors, who is now passed away, darn it. I have never seen it done, but let me tell you, if you want to do a balanced feed line, this is how you do it. You use a pair of coaxes, and I used RG58 here. A lot of people want to get into RG6 because they can get it cheap from the cable company. No, it's got to be 50 ohms. What does it say on the back of your transmitter? 50 ohms, okay? So I use RG58, but notice what I do up here. At the top, you solder those shields together. They do not touch the center conductor, because the center conductors are your east and west or north and south. That's your antenna feed, the center conductors. Now, solder those two shields, come back into the shack and solder those shields, and then take your center conductor leads, take it into a balun. See, you can see all that. 4-to-1 balun works just great. And then take that ground into your station ground off the two coaxes, as well as the 4-to-1 balun. Let me tell you something. This is a really righteous way and works great. There was a thing in an Army manual that told the troops, if you get out somewhere and you don't have any way to hang an antenna, drive a nail in a tree. I've tried this several times. Guess what? It works. Really? No, it's not a Force 12 and it's not a resonant dipole, but you'll be amazed. You'll be amazed. It's just fun stuff. Good friend Jim, AC0KN, he's Kansas City. He only had room in an attic, but he wanted to work from 80 to 2 meters, 10 bands. Well, how do you do that? Well, he did it really super. Pay attention. This is one cool antenna, and it works well. First of all, he took a piece of plexiglass, he did fiberglass, I'm sorry, and he 2 aluminum strips down each side, down on the right. You'll see what I'm talking about. And he drilled holes for the 10 dipoles and put wing nuts in them. And all of the different leads come out from there. He went into a ballon. And so, because every wire dipole really needs to have a ballon. What is a ballon? It's not a ballum. It drives me insane when I hear people say ballum. No. What does that mean? What is it? It's balanced to unbalanced. BALUN. Now, what's the deal? Just a dipole or anything of that nature it's an unbalanced antenna. So what you need to do is you're coming out of your transmitter with a 50 ohm unbalanced lead. When you go into the antenna, if you had a ballon, you could balance it. And that's why you use ballons strictly to keep the RF where it's supposed to go. And it's a transformer. So actually any of the antennas not touching, it's going through a transformer. A little bit of history on the ballon and the transformer. But here's what Jim did. All of the wing nuts and stuff. And here's how it worked up in the attic. All of these are cut to length of each one of the bands to be in the center where he needed it. Here's a little better view of it. And for all of the doom and gloomers that say, it won't work. Well, yeah, it does. I just did one shot on 40 meters. Look at it across the band. I mean, you can't want a better dipole than that. The only salvation of it was the 6 meters. But he only wanted it to work a 6 meter repeater, 2 meters, and it worked fine. I mean, it was right down to almost 1-to-1, so that worked great. So see, you just have to put your thinking cap on and look at that. He's worked all over the country with just a basic antenna as this and the transmitter barefoot. But there's just so many other things you can play with, and don't be afraid. I worked, I had this up for about 6 or 8 months when I was in California off of the balcony with a hustler. It worked terrific. And I've done slinkies. Slinkies work really good if you get them all tuned. That's the whole thing. They have to be tuned. I've used a fence post and fence lines. Again, it's not very tall, but it works. And these are just experiments over my life that I've used them because I love to experiment. And then you get into this thing of SWR. Hey, for the first 15 years of my ham radio life, we didn't know what standing wave ratio was. We didn't have SWR meters. Oh, it was so fun. And so, for all you guys, oh my God, my SWR is 2.1 or 2.5. I heard a guy the other day was 3-to-1. He had to shut his radio off. He was going to die. No, it's not. No, it's not. It's just one of these things that, I don't know, I guess we get it in our mind. And the handbooks aren't very good about it. They scare you. You get anything under 3-to-1, 2.5-to-1, don't worry about it, really. And if you're one of those guys that really worry about it, here's the answer. Put your dummy load on a tower. It'll just be great. Oh, golly. And of course, the end-all antenna for many is the wonderful, wonderful antenna that can really, really play for you. And this antenna is something that it's a little bit difficult to put up, but oh boy, it certainly does work well. Oh, here's the thing on that balun again. You can make a balun out of a piece of coax cut through the right length, but you look on the right, see, that's a transformer. And you can see how it works on the left. That works very well, very, very well, and gives you a lot of RFI going bye-bye. You get rid of it by keeping the RF out of your antenna lead. You want all your RF in that antenna. You don't want any coming back down to coax, so that's important. And a couple of other things here. What do you do about bringing coaxes into your house? What I do is I use toilet flanges on the subfloor. It works really good. I had at this particular location when I was there in the Ozarks, I had 15 coax coming out and into the room. It worked great into the crawl space and up through that, beautiful. And then we put down a subfloor, and it was wonderful. There I was testing the leads to make sure before we hooked it up to all the other stuff. But that's how I did it, and it worked really well. There's so many other things you can do with it, but what can I tell you? I've always wanted to be on 160 meters, right? You got 250 feet? No. Well, what are you going to do? Because nothing works. I'm telling you, I've tried it. Nothing works on 160 meters but a resonant dipole that's 260 feet long. Now, you're going to, a lot of guys give you all kinds of other inverted L's and all of this stuff. I'm sorry. So what do you do? Well, back in about, I think it was August, Tim Duffy, one of the guys at DX Engineering, great friend, has the couple of $1 million contest station, sent me an email and he said, hey, check this out. We just took this antenna on. This antenna is from Germany. This antenna is a true 160 meter antenna, and it's 125 foot long. But wait a minute, Heil, you just said it had to have two, but it does. Look what the Germans did. This is an amazing antenna. I laid it out here on the floor before we put it up. You'll notice the wire all coiled up, the antenna wire. But then look at that little thing right before it goes to the center insulator. It's a coil. What's in that coil? It's about 60 feet of wire. Just good old 16 gauge, I think, wire. There might be 18. Very neatly wrapped and tied. And then it goes to the feed line. Well, it does it on the other side. That's 120 feet of wire that your transmitter is seeing. Remember I told you a while ago, just get it up there. I do have 250, actually there's 260 out there of wire. It's not just in a straight line. And boy, does it work. I don't know if you can see that very well, but it's hard to see. But you can see those two little black dots. That's the two little coils of 60 foot of wire. Comes down with the feed line. Bingo. You want to get on 160, you go to DX Engineering and you buy this. It's amazing. Kelemen. Kelemen. And it really works great. Kelemen make a whole bunch of other antennas, dipoles and stuff, but it's a miracle antenna for me. And it's going across the street. I'm using another 70-foot tree of my neighbors, but they love it. You can't see it. So, and that thing's 70 feet in the air over a busy street. So, well, now what are you going to do about hooking all this up? I know. You go to the handbook and they show you how to solder through the little holes. Well, I got news for you. Nobody, you nor no one else, can absolutely guarantee me that all of the shield is soldered. You can't do that because you can't see it and you don't know. Well, that's what the handbook says, Heil, so that's what we're going to do. Well, I got news for you. When I got into this hobby, 2 weeks into it, I was on 6 meters. I hooked up with a guy that was building a 6-meter single sideband transmitter. Now, think about this. This is 1956. Sideband wasn't really happening on the low freaks. This guy was building a sideband transmitter for 6 meters. Well, he happened to be the head engineer at CBS KMOX radio in St. Louis because I was at the Fox. I'd play, we pay 8 minutes, and then I'd have 2, maybe sometimes 3 hours while the movie went on. He gave me his address one day. He said, come and see me during your time. I pulled up in front of KMOX radio. I'm 15 years old. It's like, whoa, what is this? He became a wonderful, wonderful Elmer to me. He helped me with so much. One day I took a piece of coax to him and showed him I wasn't soldered real well. He said, oh, kid, you can't do this. I said, well, that's what the handbook says. I don't care what the handbook says. That's not how you do it. He said, this is how you do it. You go ahead and trim it off and it was about maybe 3/8 of an inch of shield. Pull it back and cut it around, but then go ahead and put the center conductor in and solder that well in that center point. But then, before you do anything, you want to take that coax connector and you want to put it in a vise because it's going to get really hot. You want to tin the whole end of that, and it's going to be so hot you can't touch it, but you want 100% of solder around there. And about 15-20 minutes, cool down. Then you solder that, and you can absolutely take it to the bank. 100% of those shield wires are soldered. And I never showed it to anybody because when I started showing it to a few of my buddies, and they made fun of me. Well, that's not how you do it. Well, the CBS engine, I don't care who did it. So I finally said, forget it. I didn't talk about it, just put tape around that until, I don't know, maybe 4, 5, 6 years ago. So I visited that $1 million contest station with Tim Duffy. I look over in the corner. Now he has got, if you've never seen, look up a YouTube on him. The antennas are incredible. But coming down in the corner was this bundle of coaxes. And I went over to it because I thought I saw what I saw. They were all done like that. I ran over and shook his hand. I said, oh, Tim, thank you. What did I do? I said, you just gave me salvation after 60 years. Why? And I told him, oh, no, you don't solder through the holes. Now, this is Tim Duffy, the multi-million-dollar contest station owner and builder. You're going to argue with him? I don't think you are. I certainly don't. And so from then I said, oh, great. I don't have to wrap it anymore. So I took off my my tape. I did, yeah, what you see is what you got. But it's just so wonderful to be able to do some of these things and share it with people. But there's just so much more. You'll find me in the AM windows. Did you know there's AM windows? Maybe you don't. Write this down. Don't forget it. And please observe it. When Sideband came on to the scene about 1952 or 3, there were big wars that were happening. The AM guys were crystal controlled, and the sideband guys, they just move wherever they want. They didn't care. Well, now, wait a minute. Have respect. There's respect. I'll go where I want. I got a VFO. No. So a bunch of guys sat down they really almost came to a war. One of the AM guys paid a guy a visit one day, one of the sideband guys that were just causing all kinds of havoc. And he opened the door, and here's this guy standing there with a shotgun. Nobody got hurt, but he got the message across. I want to talk to you about your single sideband signal. This is a true story. I know, because I know one of those guys. I wasn't one of those, but I know one of the guys that did this. They sat down as gentlemen and they formed a gentleman's agreement. And that gentleman's agreement lasted for a couple of decades. But then new guys came in and AM was kind of dying off and nobody cared. I guess that's really what the deal is. Nobody cared. Well, in those days, we did. We were gentlemen about it. But from 3870 to 3890, please reserve that for the crystal controlled AM guys. 7290 to 7295 on 40 meters. 14315, and that moves around a little bit. And you please, you want to take care and be a gentleman about it. You really need to pay attention to your neighbors. Another thing about AM, the carrier limit is 350 watts. Well, my amplifier will do a kilowatt. Will it do it at a full carrier all the time? No, probably not. But here's the deal. On AM, the FCC requirement is only 350 watts. Why? Because the PEP of AM is 4 times the carrier. So if you're running 350 watts, you're up around 1400 watts. And that's only because of the peak envelope power. So you want to pay attention to that. All the new radios, I mean, all of them. One of the better radios today, for many other things, the 7300 sounds like a beautiful vintage tube AM radio. It's great. So don't be afraid to punch the AM button, 7610s, 101s, everything. In the past, I don't know, 12 or more years, any kind of radio sounds great on AM. And so you're seeing an influx of guys finding that wonderful thing that we call amplitude modulation, angel music. It's really good because the audio is broadcast audio. So you wanna look at that. You enjoy it. Let me tell you. And a lot of things are in my handbook. If you don't have this handbook, I advise you to go to your dealer, or you can go to our website and purchase it there. Those I'll autograph for you. It's really, really worth it, because a lot of the things that I'm talking about today, plus so many more, are in there. The handbook, other handbooks don't do that. I just don't understand why, but they don't. But the handbook is loaded with stuff that I learned decades ago, and I learned every day, and you will get a lot from it. I was very, very blessed some years back. Heil Sound was inducted into the Rock and Roll Hall of Fame. We're the only manufacturer in the Rock Hall. Those are some of the things we did. That's the mixer behind me there that I built for Pete Townsend and the Who for Quadrophenia. It was the first and only quad system where I could move Roger's voice around an arena. Back down on the other side is ZZ Top's mixer. We were the first company to do monitors. And I learned it from ham radio. Why? How? Because of phasing. I was able to develop that speaker that sit right underneath the microphone. Normally it would feed back, right? Not if it's out of phase. And my beloved talk box. I designed a talk box for Peter Frampton and Joe Walsh and Peter Frampton. I'm sure you've heard it. And a few years ago, I was given an honorary PhD degree in music and technology from Mizzou University. It's all of what I learned in ham radio. I barely made it through high school. Barely. My grades were terrible. I didn't care. I was making more money than my teachers because I'd been playing since my sophomore year in the theaters. I didn't need all that stuff. And so I learned it all. Really, all of this came from ham radio. As I said, I learn things every day, and I want you to learn things every day. That's why I'm here. I can come back for hours and hours on all kinds of subjects, and I appreciate you having me again. And we'll be there, and always be known that I'm here for you. Send me an email, and I'll answer them for you. Just bob@heilsound.com, or look up QRZ. You'll see some other things in QRZ you'll learn about, and quite a lengthy thing about some of that. We have any questions that I can help you with quickly?
Awesome presentation, Bob. Thank you very much. Do we have any questions from anybody? Doesn't look like we do have any questions.
Oh, we answered them all?
Sounds like it.
Somebody's got to have a question. Don't be shy. No question's dumb the first time.
Oh, I think we have a question coming up.
Okay, good deal. Good deal.
Chris W0CWA, magnetic loop antennas. Any thoughts on that?
No, I never have had really good luck with them compared to what we talked about today. But I know that guys have used them and they work good. I just haven't experimented much with them. But know guys that do have good luck, and so that's why I say you just try it, and it might surprise you how well things work, right? Do you have some loop antennas? Oh, he's gone. Okay.
Any other questions for Bob? Fantastic. Awesome presentation, Bob. We really appreciate it.
Okay. Come back and we'll find another subject to talk about, huh?
This presentation was brought to you by the Northern Colorado Amateur Radio Club. For more information, visit our website, ncarc.net. Thanks for watching, and don't forget to like and subscribe.